A fruit supplier company has delivered guava to a dining hall of a school. It was found that 5% of the guava were rotten. Okay, now let's look at the first part. If a random sample of 10 guava is chosen, find the probability that 9 of them are good. So this is binomial distribution questions. So I hope you still remember this. P x equal to r is equal to NCR time probability of success, P raised to the power of r time probability of failure, Q raised to the power of n minus r. Always make sure the sum of these two numbers always equal to the total number of try. Okay, now 9 of them are good. It means 1 is rotten. So the 5% is for the guava rotten. So now we want to find P x equal to 1. Why? Because 9 are good, means 1 rotten. Okay, n total number of try 10, C 1 time probability of success which is 0.05, 5% equal to 0.05 raised to the power 1. And always remember P plus Q is always equal to 1. This is probability of success. This is probability of failure. Okay, so if the P is 0.05, so the Q here will be 1 minus 0.05, which is equal to 0.95. And this is 1, here will be 9. Always make sure the sum of these two numbers always equal to this number. Okay, now just press your calculator. 10C1 times 0.05 times 0.95 raised to the power of 9. Okay, so the answer is 0.3151. Now let's look at the second part. Find the minimum number of guava required to ensure the probability of having at least one rotten guava is more than 0.85. Okay. At least one rotten. So at least will be using this symbol greater than or equal to more than 0.85. Okay, so this is actually means that 1 minus px equal to 0, right? We don't want 0, so the rest okay. At least 1. It can be 1, 2, 3, 4, and so on. But 0 we don't want. So 1 minus px equals 0 is greater than 0.85. So now I'm going to change the places of these two terms. This I move over here and this I move over there. 1 minus 0.85 positive, it becomes negative, and negative becomes positive. Okay, this is 0.15, and this NCR time 0.05 raised to the power 0. The power here always follow this number, and 0.95 raised to the power of, and always make sure these two numbers add up together must be equal to this number. If this is 0, here must be n. Now NC0 is equal to 1. You can press your calculator. Now let me show you. 4, let's say the n is, let's say this n, I let it be 4, equal to 1. So if I change it to, let's say for example 8, always equal to 1, right? So even though we don't know the value of n here, but we know it's actually equal to 1. So 0.15 is greater than, this is 1. Okay, let me write 1 for you. And any number raised to the power of 0 is 1, right? Except 0. Okay, if 0 raised to the power of 0 is different, you see, 0 raised to the power of 0, math error. This is an indeterminate form. Okay, so this is 0.05 raised to the power of 0 is actually equal to 1 as well. And now we left this 0.95 raised to the power of n. Okay, so 0.15 is greater than 0.95 raised to the power of n. Now I'm going to use log to help me to get the value of n. Add the log for both sides. And then bring down the n. Let me continue doing here. Okay, not equal, it's greater than. Okay, now you need to be more careful for the next step. This is actually a negative number. You can press your calculator, log 0.95. This is actually a negative number. So if you move this over there, log 0.95 divided by log 0.9, oh sorry, log 0.15 divided by log 0.95, you have to change this inequality sign. It's the same thing, like for example, if I tell you like negative 3x is greater than 6, so 6 is less than 6, x is less than 6 divided by negative 3. Okay, then for this part you just press your calculator, log 0.15 divided by log 0.95 is equal to 36.99. N is greater than 36.99. So the question is asking minimum number. Okay, so the minimum number is equal to 37. Okay, this is the answer for second part. Let's look at part B. The weight of a guava is normally, okay, this is normal distribution question, normally distributed with a mean of 320 grams and a variance 225 grams square. Find the probability of the weight of a randomly selected guava. Okay, the variance is 225, so the standard deviation will be square root of 225, which is equal to, we can press a calculator, is equal to 15. Okay, now we have all the value that we need. For part 1, more than 330 grams. More than 330 grams. Now this is x value, so the first thing, I'm going to convert it to z value. Z. So the formula that I use is z equal to x minus mean divided by standard deviation. So the x is 330 minus mean 320 divided by the standard deviation. Be careful, this is standard deviation, not variance. So 15. Okay, now let me convert it to z value first, then only we get the value from our table. So 330 minus 320 divided by 15 is equal to 0.667. Okay, I just take 3 decimal places. Now go to our table, 0.667. 0.6 7 is over here. So you just press your calculator, 2546 minus 23, you will get 2523. 2523. So the answer is 0.2523. Or you also can use your calculator to help you check the answer. Just press this menu, look for distribution, and then normal cumulative distribution. Okay, so this one you just key in 330. Okay, for the apple you just key in a very large number. Okay, let's say okay, let me key in again, 330. Oh, sorry. This one I just key in a very large number. Okay, 9.99 times 10 to the power of 99. And then the standard deviation is equal to 15. And the mean is equal to 320. Okay, let's check our answer. 0.252. Okay, a little bit difference, but it's okay. Now let's go to the second part. Now let's look at the second part. Find the value of h such that 90% of the guava have a weight greater than h gram. Okay, x is greater than h is equal to 90%. 90% is 0.9. Okay, so let me change it to z value. So h minus mean, the mean is 320, divided by the standard deviation, which we got just now, 15, is equal to 0.9. Okay, so this is actually, if you draw a diagram like this, since it's more than something and this is 0.9, this is 0.5, 0.5, right? So we know that this value must be somewhere around here on the left hand side, h minus 320 divided by 15. So the area here, 0.9. But you cannot get this 0.9 on your table. So what we need to do is, so if this is 0.9, I know that here must be 0.1, right? So property of z less than h minus 320 divided by 15 is actually equal to 0.1. Okay, now, so for me personally, I like to change it to greater than, then only I can start, then only I start get my answer from the table. So what I'm going to do now is this. It's actually this 320 divided by 15, which is over here, right? Less than. So here is 0.9, this is 0.1. But for our table, we always need to find greater than, right? I mean this table. I hope that you still remember how to use this one. So what I'm going to do is, this part I can diffract it to the another side, become here. And what I'm going to do is, I'm going to change the position between these two numbers, 320 minus h divided by 15. Okay, why do I do so? Now, for example, let's say this is, for example, let me simply give you a number. Let's say this is negative 3. So if that refracts over here, it will become 3, right? Now, so negative 3 can be let's say 3 minus 6, right? So if I refract to another way, I just need to change these two numbers, their position. It becomes 6 minus 3. So is this correct? 6 minus 3 is equal to 3. So 3 minus 6 is equal to negative 3, right? So now I'm applying this concept for this one. If you don't want to do this way, you also can do another way. You just simply add a negative for it. But be careful, it's negative, it's like the middle, not only for h, but for this whole thing. Okay, you see, if you add a negative for it, if you bring in the negative, it will become negative h, negative negative become positive, right? Which is actually equal to 320 minus h divided by 15. It's the same thing, right? Okay, so I'm going to write 320 minus h divided by 15. Now, here I'm going to change it, become greater than 320 minus h divided by 15 is equal to 0.1. Okay, property for this is equal to 0.1. Now, I want to get the value for the h, which is inside the parentheses. So I'm going to start from the inside, here. So what I'm looking for is 0.1. Be careful, not look at here, but you have to start inside here. Look, get the value from inside the table. 0.1 is okay. 0.1. I need to minus 3, so I don't have 3 over here, so I just take 2. 1.2, 1.281. Okay, so 320 minus h divided by 15 is equal to 1.281. Is it correct? 1.281, yes. So what I'm going to do now is just find the value of h. So 320 minus h is equal to 1.281 times 15, which is equal to 19.215. Okay, 320 minus 19.215 is equal to h, and h is equal to 320 minus 19.215. Okay, 379. Okay, this is the value of h. You also can use your calculator to help you to check the answer. Now, go for distribution and then inverse normal, but be careful, your calculator is for less than for this inverse normal. So this is 0.9, I need to key in 0.1, and then the standard deviation 15. Let me check, standard deviation correct, and the mean is 320, correct. Okay, so this is our answer, 300.7. Okay, slightly a little bit different, this is okay. So this is the way how do we solve this sub question.